times the cubed root of 5. It's not 2 cubed times the square root of 5. It's 2 times the cubed root of 5. Make sure it is obvious where that little 3 is. Okay? Now, you may call this a trick question, but it's just really a thinking question. Can you find the square root of a negative number?
No.
Why not?
Because anything squared is positive.
Anything squared is going to give you a positive answer. Okay? Now, we can find an answer, but this would be it's not a real number. It would be imaginary, and we're not ready to deal with that. So for now, we're simply going to say it's not a real number. Okay? Or you could say no solution. No, there is a solution. We're simply going to say not a real number. All right? Because we are saying what number times itself gives me negative 25? Nothing. But can I find this?
Yes.
What's the difference between this and the one before it? This is on the outside. So we're saying basically I want the opposite of the answer to the square root of 25. Well, what is the square root of 25? And what's the opposite of that? Okay, so you can find this.
What's the square root of negative 1?
Huh?
Be the square root of negative
No,
1? Or just negative 1?
just negative 5, because the square root of 25 is 5. Okay? Can you find the cubed root of a negative number? Can you cube a negative and still get a negative? Yes. Okay? The answer to this is negative 3. Now, taking this and then putting it in a broader perspective. Can you find the even root of a negative number? Will you ever be able to find an even root, meaning 4th root, 6th root, 8th root, 10th root of a negative number? No, because if it's being multiplied an even number of times, this would have to be positive inside here, right? Okay? But is it possible to find the odd root of a negative number?
Yes.
Meaning the 5th root, the 7th root, the 9th root? Yes. Okay? So, that was to show you in general, when can I find an answer and when can I not find an answer? All right?
When you say negative 3, where you put that at?
No, it's just negative.
It's just negative 3. Negative 3. 27 is a perfect cube. 3. And the negative, this means that negative 3 cubed gives me negative 27. Okay? But I don't want to cube it. I'm looking for the cubed root. All right? Now, what happens when we're dealing with variables? Now, we said if I raise a power to a power, what do I do with those exponents? Multiply them. Well, if I'm not raising a power to a power or cubing, I'm taking the cubed root or the square root instead, what am I going to do with the exponents? You're going to divide them. All right? This, taking roots of variables, is a matter of division with remainders. Watch this. What root is this? Square root. So basically I'm saying, how many times can 2, the square root, go into 3? How many times? With a remainder of 1. That means that I can take 1/8 out of here I can take 1A out, and I have 1 left underneath. For the B, how many times does 2 go into 5? Twice, right? With a remainder of 1. That means that I can take 2 B's out, and how many are left? 1. For the C's, how many times does 2 go into 7? With a remainder of. So that means I can take 3 C's out, and I have 1 left underneath. Okay? Because basically what we've looked for is how many groups of 2 are in A cubed? 1 group of 2, because that's A squared times A, right? That's 1 group of 2. How many groups of 2 are in this? 2 groups of 2. And 1 left over. How many groups of 2 are in this? 3 groups of 2. And 1 left over. You remember how we said to check ourselves? You take this outside and square it and then multiply by what's left inside. What's A squared? A squared times A. What's B squared squared? Times B. B fifth. What's C cubed squared? C to the 6th times C. C to the 7th. Okay? When you're dealing with variables, it's basically division with remainders. Okay? Let's look at another one. If we were looking for the 4th root of all this stuff. Caleb Dishler, wake up and pay attention. Can 4 go into 5? How many times? Once. So I can take out an A to the 1st power and think about it in your head. Long division. 4 into 5. What's your remainder? You have a remainder of 1. Can 4 go into 12 for the B's? How many times?
3.
So we can take 3 B's out. Is there a remainder? So what does that mean? There's no B left underneath. There's no remainder. Can 4 go into 15? So I can take 3 C's out. Do that in your head. What's your remainder?
3.
3. So that means you still have 3 C's under the radical. And my radical is the 4th root. You have to have that little 4 in there. Okay?
Hey, where'd the D go? Oh, yes.
I took them all. It was a perfect 4th root. It was perfect. Okay? Yes? How do we check it? All right, well, instead of squaring all this stuff, we raise it to the 4th power.
Well, you have to keep it 4 in there for the answer to.
Yes. A to the 4th power is A to the 4th times another A gives me A to the 5th. B cubed to the 4th power is B to the 12th. C cubed to the 4th power is C to the 12th times C cubed is C to the 15th. Okay? Try this one. What is it?